Hello all. In this lecture we'll see the second part of functions. So in this function we'll see about parameter passing. That is mainly we'll see call by value, call by reference and how to pass arrays to functions. So parameter passing. So what do you mean by this parameter passing? So it is a technique used to pass data to a function. So if you want to pass some data to a function, we call it as parameter passing. So we have already seen that example. So if we want to pass some data from main function to sub function or the function, we will use the technique known as parameter passing. So it will be when we call the function, we will be passing the values to the function. So there are two techniques for parameter passing. So one is call by value, or we can call it as pass by value also. The second technique is call by reference or pass by reference. Okay, we will see each one separately. So call by value, in call by value, what it does is a copy of the data is made and the copy is sent to the function. So when we call from main function, a copy of the data is made and this copy is sent to the function. So copies of the value held by the arguments are passed by the function call. So we know it is arguments and parameters. So when we pass it, what happens is the copies of the value held by the arguments are passed by the function call. So when we call, the copy will be passed. So only copies of values held in the arguments are passed by the function to the formal parameters. So actual and formal parameters are there. So what it does is the argument's value will not be changed. Only the parameter value, that is inside the function only, the values will be changed. So values in the arguments or the actual parameters remains unchanged. So when we call it, the actual parameters remain unchanged. Okay. So we will see that example. Before that, we will see call by reference also. So you will understand this call by value after seeing this example. So here you have to remember that we are passing only the copy of the data is made available and the copy is sent to the function. So in the main function, the values remain unchanged. The function can change the values inside the function only. Main function, the values remains unchanged. I will show an example, then you will understand that. Then we have call by reference also. In call by reference, it sends the address of the data rather than a copy. So in the previous case, it was the copy of the data. Here we will send the address of the data. So call function can change the original data in the calling function. So that is the advantage. Okay, so in the call function, the call function inside the function, it can change the original data as a function. So, but C does not support this pass by reference or call by reference is not supported in C. But we can use it if we want to change the data of a calling function. What we do is we pass the address of the variable. We'll pass the address of the variable. We will see that example later. Okay. So when we learn pointers and all, we'll see this call by reference in detail. So in this lecture, we'll see just call by value. Okay. So here C does not support, even though it does not support, but if you want, you can pass the address. So actually here the address of the data need to be sent rather than the copy of the data. But in C, we can send the address of the variable, not the data. We can send the address of the variable. So actual call by references, we have to send the address of the data. Okay. But in C, it is not possible to send the address of the data. We can, but we can send the address of variable. So address of variable can be sent. So we will see an example, then you will understand this thing. So this is an example for call by value. So we have a function here. This is a prototype mul my 10. This is a function name. So you can use any function name. So mul my 10. So we are going to multiply something by 10. If we give an input number 2, then that 2 will be multiplied 10 times. So that is a function, main function, that is a use of this function. So the name of the function is multiply 10, and the one parameter that is to be passed is in num. So you know that you did not mention the variable name also. This way also you can write the program. So I have mentioned an array, a variable name. Then int main void. It is not necessary that you should use this void and all. Okay. Then I am declaring two variables result and num. I am initializing it to 3. Okay. Now you are printing this value of num. Initially you are printing before the function call. So num be equal to percentage d. So percentage d will be replaced by num. So it will be 3 here. Num be equal to 3 before function call will be printed. Then what we are doing is we are calling the function mul by 10 of now. So we are passing this data. So this is call by value. So call by value means we will be passing this data num to the function. So a copy of the data is sent. So we make a copy of the data and that copy is sent to this num value. So num here is 10. So it is a copy. Now, now we are multiplying num equal to num into 10. So 3 into 10 is done here. 3 into 10 is 30. 3 into 10 is 30, and that result return num means 30 will be returned. So 30 comes here, that 30 will be stored in result. So will be assigned to result. Now we will be printing this result equal to percentage d. So result will be print here. Percentage d after a function return from function. So percentage d. So result equal to 30 will be printed. Now if you try to print num, so num value we have changed inside the function to 30. But here when we print this num, it will be 3 only. Because we are sending in this call by value, we are just sending, we will run this program. Okay. So when we run this program, so you can see this num3 before function call. So before the function call, num equal to 3. Here this statement is num equal to 3. After that result 30 will be printed. That is correct. Then after that again if you print num here inside the main function, it is 3 only. Because what it does is it is called by value or passed by value. So what it does is only the copy of the data. So num's copy, num value is 3. That copy of that 3 is stored in this num. Okay. So that num value is changed inside the function. It is a copy of the data. Num is different here. This num and this num is different actually. This is copy of that data. So even though we change that num value in this function and num value is 30 inside the function, but when we print in the main function the num value, it is 3 itself. It won't be changed. But if you print the num value inside this, so if you want, you can print the num value inside this. I'm copying it. I'll I'll copy it again. I'll print it here. Okay. Sorry. Sorry. Okay. There's some problem here. Okay. So what I'll do is I'll just print it here. Okay. I'll just copy. I have copied that function. It's not copied. Okay. I have copied it and I have print it again. Num equal to num. I'll mention it as inside function. So I'll mention it like this. So inside function. So I'll print it here also now. So if we see this program, so num equal to 3 before function call, num equal to 30 inside the function. So num value has been changed inside the function. and result equal to 30 is here, but the num in the function, main function, it is 3 itself. Okay, num equal to 3 is in the main function. So this is known as call by value. Here we are passing only the data or copy of the data. We are not passing the actual data, or we are not passing the reference. It is called by value. We are passing the copy of the data. So that copy of the data is created and it is transferred here. So the actual num value will remain the same. This is another program. It is to find the GCD of two numbers. So greatest common divisor of two numbers. So we have two numbers. So we have to enter two numbers. So we have declared in. So this is a function prototype. We have two parameters that have to be passed into two integer things. Then in num1, num2, then we have to enter two numbers. So it is scanf percentage t. So it will be entered into. So if you enter 12 and 15, num1 will be 12 and num2 will be 15. Now we are calling this function GCD of num1 and num2. Now the copy of this 12 and 15 will be passed here. So x is 12 and y is 15 now. Now here we have initialized this result equal to 1 and k equal to 2. So k is 2. What k does is k will start from 2. It will check whether 12 and 15 are divisible by 2. If it is divisible by 2, then result is becomes 2. If it is not divisible, what it does is k value will be incremented to 3. Then it will check whether 12 and 15 are divisible by 3. So 12 and 15 are actually divisible by 3. So result becomes 3. Then after that, what it does is k value is incremented by 4. Then it checks 12 and 15 divided by. So it will go on until this k value becomes greater than x, or k value becomes greater than y. So this is the program. So we are here, x is 12 and y is 15. Now this loop will be repeated until k value. That means the divisor cannot exceed the actual number. So if it exceeds 12, x is 12. So if it exceeds 12 or k value exceeds y 15. So if this happens, then what it does is it will come out of the loop. So it will continue this execution until this k value is less than or equal to x and k less than or equal to y. Okay, so if what it does is inside the loop, for the first k value it is 2. So it will check whether x mod k and y mod k equal to 0. If both are divisible, then the k value will be assigned to result. So that GCD value, greatest common divisor of that both those two, will be result. Then k value is incremented. Again, it will check this condition. It will go on repeating until it becomes that. So if we give some value like 24 and 30, so initially result will be 2. After that, when it becomes 3, 24 and 30 are divisible by 3 also. So result becomes 3. After that, 4. 24 and 30 is not divisible by 4. Next it is 5. It is not divisible by 6. So 24 and 30 are divisible by 6. Then it takes 7, 8, 9, like that it will go on. Okay, finally you will get some result. So if you run this program, so you will be asked to enter some values to numbers 12 and 30. So I am entering 12 and 30. So greatest common divisor of 12 and 30 is 6. So initially 12 and 30, result will be 2. After that it will be 3. Then 4, 5 and all are not divisible. Then 6 it becomes. Then it goes on repeating until k becomes 13. When k becomes 13, this becomes false. So it will come out of the loop. So this is the way. So here we are printing this thing. So only the value is called by value. Only the copy of the data is transferred here. Okay. So I'll show another example. This is to check whether it is prime number or not. Where you have to find the prime factors. So the prime factors of a number. So here, this is the function boolean. So we are using another return type boolean, bool. There is another return type, data type, bool. So it is included in this std bool.h. It is not necessary that you should use this boolean function. In a previous example, we have seen that int can also be used. See, what happens is in bool we can return true or false. So we can return true or false. So here the return type is true or false. That is why we are using boolean function. Boolean. So boolean means true or false. So it is if you are using this kind of data type, then you have to include that std bool.h. This is a header file that should be included. Then what we do is int in, and we have d equal to 2, so d will be initialized to 2. Then we are asked to enter a number, so I will be entering some 30. Now we have to find the prime factors of 30. So you have to get the prime factors of 30. So prime factors of 30 is we will be printing that prime factors of 30 is like that, it will be printed. Now we are repeating this loop. For inside this loop, what it does is we will start the first prime factor is 2. So we will check 2 if 2 less than or equal to n by 2. We have to repeat only up to 15 because no prime factor will occur above 50. If we are giving 30, 30, then below above 15 means it cannot be. The maximum is 15 into the 230. So that is why we are repeating only by n by 2. So 2 less than or equal to n by 2. So 2 less than or equal to 15. So what it does is we will check whether n more d. So it is 30 more d, and we have to check whether d is a prime number. D is a prime number. So we are using a function inside this if statement is prime of d. So what it does is it will call this function is prime of d. D here it is 2. So x is 2 here. Now what we will do is we will check whether this is a prime number. So for d equal to 2, d less than or equal to x1, then if x more d equal to 0. So this is actually to check the prime number. So it is not necessary that you should use this kind of thing here. If it is true, if this divisible is happens, then it will return false. That means it is not a prime number. If it is false, if it is not true, then it will return true. Okay, so what it does is we can check with an example. So you will be asked to enter a number. So I am entering this 30. Now the prime factors is 2, 3, 5. So this loop will be repeated here. So each time it will be calling this function to check whether it is a prime number. So what that prime factor, so 2, 3, 5, 4, 5, 6, 7, 8, like that, some numbers will be initialized or incremented. So we have to check whether number is a prime number or not. We have to get the prime factors only. So that checking, prime number checking is done in the isPrime function. So here isPrime will simply check whether that number is prime or not. So what that d is prime or not will be checked here. Okay. So you can see that we are using a d here. Inside this we are declaring another variable. Okay, we'll see about that scope and all later. So this d is different from this d, or this x is different from that x and all. So it is not necessary that you should use this boolean and all. So instead of boolean, you can well use int also. Int is prime. What you have to do is, so int is prime, and you can here also you can use int also, but only thing is you have to return some 0 here. So it should be some integer value, and instead of true you can return 1. Okay, then also you will get the output 30. So prime factor is 30. So it is this way also you can do. It is not necessary that you should use boolean and all return type. You can use also integer type. So only thing it does is it's prime. It will check whether it is prime number. If it is prime number, it will return 1. So 1 and any number, 1 and or if it is 0, then it will be false. Otherwise it will be true. So one, you know the condition for true. True means any positive number. So this way it happens. So you can use this function inside a if statement also. So whenever it is used here, what it does is it will simply call this function. It will call this function and it will return some value, and that value will be checked with this value. Okay. So we'll, before going to this, next is array. So call by reference we will see later how to, when we study pointers and all, we will see. So by using the address also, we can change, that is we can pass the address of the variable. Okay, in call by reference mechanism, this is not actually supported in C, but we can use another method, that is address of the variable can be passed. Now next is passing arrays to function. How to pass arrays to function? So we have seen simple variables. We can see, we have already seen how to pass the values of variables like x or y or gcd. When we saw that number 1 and number 2, those values have been transferred. Now if we want to pass an array to a function, for example if we want to sort an array, so we have to pass that array to that function. So how to pass that array of the arrays to function? So here what it does is address of the array is passed and not the copy of the complete array. So that is the difference. So in variables, when we pass variables, actually the copy is passed. Here, when we use arrays, address of that array is passed. Address means the starting location of the address array. For example, if it is an integer array, then if it's the starting address is at 2000, then we know that integer takes 4 bytes according, depending on the compiler. If that integer takes 4 bytes in that compiler, what it does is at 2000 the first element will be there, then 2004 the second element will be there, 2008 the third element will be there, like that it will be going on. So only the address of the first element of the array is passed and not the copy of the complete array. So address of the to the first element is handed over to the function. So only the first element address is transferred. So if it is a float array, we know that it will take 4 bytes or 8 bytes, or if it is double, it will take 8 bytes, like that we know. So only the first address need to be passed. Then we have to add plus 4. Then we will get the next element, like that. So function has the ability to modify the contents of the array during its execution. So that is the advantage when we use when we pass this address of the array. So function can change the contents of the array during its execution. So in the main function also, that array value will be changed. So we'll see an example, then you will understand by what is this statement. So here we have, I'll remove this void and all. Okay. So here I have a function prototype, void change is there, and here this is an array int, and I am using simply square brackets. I am not giving any name. You can, if you want, you can use name also. So I am simply mentioning a. If I want, I can use. Otherwise, if it is an array that is to be passed, you can simply mention int square brackets. This means an array is transferred to this function. An array should be transferred to the function. And here we have int main, and we are declaring an array, and we are initializing 3 values int arr. So arr of 0 is 1, arr of 1 is 2, arr of 2 is 3. Now this is void array, so there is no return type. So that is why we are simply calling. So we need not to assign to any value, because it is simply we have, it is a void return type. It is not returning any value from the function. So we are simply calling this function, and that array is transferred by the name arr. So arr means it is actually the address of the first element. It is actually the address of the first element. Arr, simply if you are mentioning arr, it means it is the address of the first element. For example, if arr is stored from starting address is 2000, then arr of 0 is 2000, then arr of 1 is 2004, arr of 2 is 2008. So we'll be, when we call this 2000, that address location, it is not transferring the whole array, it will be transferring only the starting address or the first element address. So if the first element is at 2000, that 2000 will be passed here, and we are using another name here, my array. So my array will be pointing to the same address location of the first element. So we are simply mentioning my ARR, and we are not mentioning any size and all. We are simply mentioning square brackets. So what it does is, this array will also point to the same address location. So now if we see ARR, if for example ARR equal to ARR's address value is 2000, then what we can see is, here what happens is, here my array, my underscore ARRY will be also point to that same address location. So it will be pointing to the same address location. Okay, so ARR will be pointing to the same address location. So this I'll write it here itself. And here my ARR will also be pointing to the same address location. Okay, now if you take this will be pointing to, so my ARR, it will be since it is a zeroth element, means first element, so it will be pointing the same address location. And my array of 2, it means it will be pointing to the third element, so 2000, 2004, 2008. So this will be at the 2008. Okay. Okay, now you have to understand this. So ARR means the starting element will be, so here I'll copy it here. Okay, sorry, ARR, it is 2000, it is, let it be. Okay, so I'll copy it here. So this here ARR will be at 2000. So this 2000 address will be passed here. So this is an integer array. So my array address will also be at 2000. So my array of 0 will be at 2000. My array of 2 will be the third element. So it will be 2008. Now we will be simply returning, since it is a void function, there is no return value and all. It will be simply returning to the main function. So it will come back here. So the next statement is printf. So we are printing elements are percentage d, percentage d, and percentage d. That is, we are printing ARR of 0, ARR of 1, ARR of 1. So ARR of 0, it is at 2000. So 2000 will be printed. The whatever the content in the memory address location 2000 will be printed, then 2004 will be printed, and 2008 will be printed. So 2000 at address location 2000, we have changed the value. So it was initially 1, and we have changed the address value to 10. So my error of 0 and error of 0 are pointing the same address location. So here it will be 10 that will be printed. Then error of 1, so it is at 2004. So at 2004 it is 2. So 2 will be printed. ARR of 2 at 2008. So we have changed the content from 3 to 20. So 20 will be printed. So if you run this program, so if you run this program, you can compile it and run it. You can see that, so elements have been changed to 10 to 20. Now we are printing the same thing, ARR of 0. We are printing actually ARR of 0, ARR of 1, and ARR of 2. So when we print this ARR of 0, even though at main program it was 1, 2, 3, it is not printing 1, 2, 3. It is printing 10 to 20. Okay, so this can be considered as a call by reference, because we are passing the address here. We are passing actually the ARR address value. It is not actual pass by reference. It is actually passing the address of that variable. We are passing the address of that ARR to this function. Now my array and ARR are pointing to the same address location 2000. So whatever changes we make inside the function for that array, it is reflected in the main program also. So that is the difference between ordinary variables and array variables. So whenever we change that array values, it will be reflected in the main program also. We have changed these two values, and it is reflected in the main program also, because we are manipulating the address location because they are pointing to the same address, and we are making changes in that memory location. So we are simply printing that whatever thing that is there in the memory location. So that memory location values have been changed to 10 and 20. So that is why 10 and 20, 10 to 20 is printed instead of 1, 2, 3. Okay. So that is the difference between array and ordinary variables. So you have to understand this thing. So we have seen this example here. So when we saw this example here, even though we are passing this num and we are using the same variable also, even though we are using that same variable, that num value is actually changed inside the program, but it is not reflected in the main program. Okay, so that is array. Then we'll see another example. So this is another example for sorting. So we have to pass an array here. So we have to pass, this is a prototype, void, this is also return type is void. Then sort is the function name, and we have to pass an integer array and an integer. Okay, so in the main function, void main, sorry, in main, so you can remove this, it is not necessary. Then you are using a variable int I. Now I am initializing this array, or you can get array values from the user, but I am using 10 values, so I have initialized 10 values, and this will be stored. So if ARR it is at 4000, so if it is at 4000, the first element will be at 4000, the second element will be at 4004, the third element will be at 4008, like that it will be going on 4 bytes. So since it's integer, it will be using 4 bytes. So 4000 at 3 will be at 4000, 2 will be at 4004, 7 will be at 4008. Now we are printing the array before sort. So we are simply printing this print I. We are simply printing ARR of 0, 1, 2, 3. Will be printing that array elements. Then after that we are calling this function. So since it is void, there is no return type. So we are not storing it anyway. We are passing this ARR comma 10. 10 means the size of the array is passed, because the function doesn't know the number of elements in that array. So we are passing, what we do is we are passing the address. ARR is 4000, and the second thing that is passed is 10. It is needed because 4000, then this function doesn't know it has 10 elements. It will be continuing, so 4000, 4004, it will be going on repeating. So the function should know the number of elements in the array, so it will be passing that 10 value also. The size of the array is also passed. Now what it does is, so here A is, so here A is 4000 and N is 10 here. A means the address of that array. So here it is 4000 is passed. Now we are using that same bubble sort is used here. We are using some two for loops. So the outer for loop I equal to 0, I less than or equal to n minus 1, that is 9, then plus plus I. So I is initially 0. Then here in the inner loop, this is also another way to do the bubble sort. So j equal to 0. Here this inner loop will repeat j less than n minus I minus 1. So I is initially 0. So n minus 1. So 10 minus 1, it will be 9. So j is 0, 0 to 9. Then it will check whether a of j is greater than, that is a of 0 is greater than a of 0 plus 1. A of 0 plus 1, that is a of 1. So if it is greater, then we have to swap it. We have to swap it. After that, again, j value is incremented. J value is incremented by 1. Then j equal to 1 and 1 less than or equal to n 9. So again, a of 1 is compared with a of 2. So again, if it is so, then again it will be swapped. Like that, it will be going on repeating until the highest element is stored in the last array. Then after that, I will value will be incremented like this. It will be going on repeating. So this is actual sorting. So here we are not returning anything. There is no return statement. So you can include a return statement, even though I have not included. You can include a return statement also. After the execution of this program, you can simply return. Since it is void, you can use this simple return statement here. So this is the thing. So this is actually sorting. So what we do is we are sorting in the A array. So A array is sorted, and ARR is not sorted. But whenever whatever happens is in this A array, it will be reflected here also. Then we are printing this array, the array after the sort, and we are printing ARR array. We are not printing A array. We are printing ARR array. So if we run this program, so the array before sort is like this 3 2 7 for everything. And after that, this print statement is printing actually the same ARR, but those changes that we have made in the function in A array, it is also reflected here. So we are sorting that array. So we are actually sorting A array inside this function, but A array and ARR is pointing to the same address location. Okay, so since it is pointing to the same address location, whatever changes we make in the function will be reflected in the main program also. So whenever we print this ARR, we will get the say sorted array itself 0 1 2 3 4 7. That sorted array will be printed. Okay. Then this is another example. So we have declared constant also here, size equal to 50, and we are using function average age. So we will be entering some students. So we can enter 10 students, and we will be finding the average age of those students. So we'll be finding the average age of those 10 students. So this is an integer array, and we are passing an integer value also, this main function. Then the array size is b of size. So size we have already declared as v. It is not necessary, you can simply include b of 50 also, but I have used size here. B of size means b of 50, that array size is 50 size. Now I have float average. Then we are entering how many students are there in the team. You can enter any number of students. N value is number of students. Then age, so you are asked to enter the age of students in the team. So this loop will be repeated. If you are entering 10, number of students as 10, this loop will be repeated 10, and b of 0, b of 1, so those array values will be stored. Okay, let the b array start from 5000 address location. So if it is starting from 5000 address location, 5000 address location. So then the second element will be 5004, 5008, like that it will be going on. B of 0, B of 1. So it will be stored in all those address locations. So 5000, then after that 5004, 5008, like that it will be going on. 5008. Then average, this is a function, so we are calling. So since it is a there is a return type for this, it is float return type, so average is float here. So whatever that is returned from this function will be assigned to this average. So we are calling this function, and we are passing b. So b is actually the address location of the starting element, that is 5000 and the n. So if you have entered 5 students, then n value 5 will be transferred here. Now here a is actually address location, that is, so it is 5000 and n is 5 here. Now we are manipulating this thing. So we are simply calculating the average. You know how to calculate the average. We will be summing all the age values of that array elements. Then we will be using that sum divided by number of students. We get the average. So that average will be returned here, and it will be printed here. And the average age of students is say will be printed. So if you run this program, so if you run this program, you will be asked to enter the number of students. So I am entering 5. Now you will be asked to enter the age of the students. So 23, 24, 22, 21. You can enter 5 students average. So 25. Then the average of the students is 23 will be printed. So what it does is it will be passing this just a starting address of this thing, and the number of elements. So number of elements also need to be passed. Otherwise, this function doesn't know the number of elements in that array, because even though it is 5 elements only is stored, the first element 5000, like that it will be going on infinitely. Okay. In order to stop that, we need to know the number of elements also. Then we can see another function. It is to find the maximum of element in an array. So this is the same function. So here we are using this function. This is a prototype maximum. We are passing an integer array and int. This is the main function. This is array. So we are storing 5 elements. So in the 5 numbers, we are storing it in values array. So there will be some address value here. Let it be 4000 anything 4900. Let it be the starting address of that array will be at 4900. Then the second element will be 4904. Like that it will be going on. Okay, then we are calling this function maximum, and since it is an integer array, so it should be returned to a maximum. It should be assigned to some integer variable. So we are using integer. So this is a function called values. Values is the array. So values is the array. So here, what it does is it will be passing that array value. That is array value. The starting address is 4900 and the 5 will be passed. So we can pass constants also. We have already seen. So values and that 5 will be passed. So here we are using the same name. It is not necessary that you should use the same name. We have already seen that. So here it will be 4900 and the 5 will be got here. N is 5. Okay. Now we are simply calculating a maximum value. So you know how to calculate the maximum value. So initially maximum value, first element is will be considered as maximum value. Then inside this loop you will be repeating, you will be checking this first element or the second element with this maximum value. So with the first element, if it is greater, then you will be assigning that values of 1 as the maximum value, and this loop will be repeated until it checks all the array elements. After that we will be simply returning the maximum value. So maximum value as the maximum element in the array. So max will be maximum value, then we will be printing that max value. So if you run this program, you can, so you have to enter some 5 values. So I am entering 87, 34, 23, 12. So the maximum value in this array is 87. So my 87 will be printed. So maximum value is 87 will be printed. Okay. This is another example. So how to pass strings? So strings can also be passed like arrays. So array strings we have already seen. Strings is actually array itself. So we can pass strings also. So this is a program to pass strings to functions. So here we are using array for function prototype. We are calling it a string copy, and it is void return type, and we are passing a character array, that is string array, and another character array. So we are passing two strings to that function. Okay, we have to pass two strings. So this function is actually to do the string copy. We have to copy from one string to another string. So this is actually function to copy. Okay, we have already seen string functions and we have seen strcpy. So we are trying to change, we are trying to write our own string copy function rather than using the inbuilt function. Okay, this is actually to copy from one string to another. So we are declaring two arrays, a of 100 and b of 100. So this is the source string and this is the destination string. So what we have to do is we have to copy whatever that is there in the a to that b string. So print of input string, then we are entering scanf. This is scan set, you all already learned. Whenever that new line character, until that new line character occurs, everything will be stored in that a string. So we'll be reading the first string. Now what we have to do is we have to copy this a to b. So we have to copy this a to another string b. So we are calling this string copy function. We are, so since it is void return type, we have to use no variables to store it. So string copy b comma a, b comma a. So b, so what it does is, if b is at, so if a's address location, so a's address location is at 7000 and b's address location is 8000, then we will be passing 8000, that address value 8000 and 7,000 will be passed here. So 8,000 and 7,000 will be passed here. Okay, 8,000 and 7,000 address locations will be passed here. Now, so 8,000. So here we are using different variables D and S. So D is actually address of the first string, that is B's address location, that is 8,000 comma 7,000. Now we will be manipulating at in these address locations. So what we have to do is we have to copy this S to D. This is source string and we have to copy it to this D. So whatever there is in this address location, it has to be copied to 8,000. Here we need not pass the array size. Since it is string, we need not pass the array size because every string will be terminated by that null character. /0 is there. So we know the termination of each string. So this array can store up to 100 characters. But we need not go to travel to the 100 elements because if we find that terminating character, if we find that /0, we can stop that. So that is why when we pass these two strings, we are not passing the size of those two character arrays. We simply pass the starting address only. Now int I equal to 0. Now the source string, we are simply printing the source string. So we will be printing whatever it is there in the 7,000 address location. So whatever it is there in the 7,000 address location, that will be printed here. Now we are going to copy it. So we are simply using a for loop here. So for I equal to 0, and that loop should repeat until s of I not equal to null value. So we know the terminating character of the source string will be /0. So it should repeat until that /0. What we have to do, we have to copy this s to di. Simply we have to use this thing. So whatever s of 0 will be copied to d of 0, then s of 1 will be copied to d of 1, s of 2 will be copied to d of 2. Like that it will be going on. Then finally when s of I becomes 0 /0, it will exit the loop. Now here we are using this statement also, s of d of I equal to s of I. So this is the every string, you know that every string should be terminated by a null character. So now if hello is we'll see that example, we'll imagine that this source string is actually hello. So if it is hello and the last character will be /0. So this is 0, 1, 2, 3, 4, 5. So last element will be /0. So it will be I equal to 0. So h will be copied, then I equal to 1, e will be copied, like that. When it becomes /0, it will check /0. Since it is /0, it will come out of the loop. Now d of I, that we need to enter a terminating character also. So actually here, after repeating this loop, d of I becomes hello. Now that /0 is not there. Okay, hello is there. Now /0 also need to be included. So in the after repeating this loop 5 times, so after repeating this 5 times, the d of I will be hello. Now we need to include that /0 or null character in d of I. So for that, what we do is we simply copy s of I is now s of 6, sorry, 0, 1, 2, 3, 4, s of 5. So here after ending this loop, when it comes, I is at 5. So s of 5 is actually /0. So we will copy that s of I character to d of I. So this what it does is now hello this d of I becomes hello and /0 will be included by after doing this statement. Or if you want, you can simply use this d of I equal to within quotes single quote /0 also. So if you are confused with this, you can simply may change this assign statement d of I equal to within single quotes /0 also. Here actually s of I means s of 5 is there. I becomes 5. When I becomes 5, it will come out of the loop if you are giving this hello /0. Okay. So we'll run this program, and we are not using any return statement. You can include that return statement also. If you want, you can use a blank return statement also, even though I have not used any return statement. So you can use that return statement also, because since it is void, it is not needed. Or you can use as a last statement you can use. So source string and destination string. So when we print, we are printing actually B here. Actually A was hello world, and we are printing B here. When we print B also, we will get as hello world, because that string has been copied here. Okay, so you can use a return statement also. If you want, you can use a return statement. Simple, since it is void, you can use a return statement also. Okay, so you can run this program. So whatever you enter will be copied to the other array, and that array will be printed. Okay, so this is actually the second array, B array, that is being printed. So, but we are changing the D array, and D and B are pointing to the same address location. So one more example, it is for matrix multiplication. So if you want to pass two arrays, so what it does is, this is void is a return type. Then matrix arithmetic, we will be adding and subtracting two matrices. If you want, you can add, or if you want subtract, you can subtract those matrices. So matrix arithmetic, this is a function, and we are passing two arrays. So when we passes arrays, that size is important. So here the column size is important. When it is two-dimensional array, that column size is important here. So this column, we have already defined row and column as 2 and 3. It is not necessary. Inside the program also you can change. So if you are not declaring anything, you can simply mention as double brackets. So in here, column size is important. So that is why we are including here. Now we are declaring two arrays, ARR and BRR. Sorry, A and B, which is row and column. So A of 2, 3 and B of 2, 3 is here. Now we are asked to enter the elements of the first matrix. So we have to use two loops. So then A of 0, 0, 0, 1, like that it will be entered. There will be 6 elements will be entered in this array. Now enter the elements of the second matrix. So you will be scanning, and you will be getting the second elements used in the B array. Now what it does is, we are simply calling this function. Math underscore arithmetic of A comma B. So we are passing the address of A and B. So address of A and B will be passed. The starting element. The first element address will be passed here. So the starting element address will be passed here, and here this column is needed. Whenever you pass this two-dimensional array, this column is needed. You need not mention the row address. Row element is not needed, but this column element will be needed. So the address, first element address will be passed here, and it will be stored in the as A, and the second array B will also be passed here, and we know the number of elements also. We are using another C element array, because to store the result we require another array. Then we are using IJ. Then user will be asked to enter. So everything is inside this function. Printf, for addition you have to enter 1, or for subtraction you have to enter 2. You will be getting the choice from the user. Based on that choice, inside this for loop, if choice equal to 1, so if it is addition, you will be adding this, and C becomes the addition of those two matrices. If your choice is 2, then you will be subtracting. If any other choice, we will mention as invalid choice, and we will be returning it. Now the resultant matrix will be printed. You have to use two double loops and two for loops, and C will be printed. So if it is addition, C will be added. Then you are simply you are using two lines, two new lines to print it in new lines, and there will be a return function. So the only thing you have to notice, that column value need to be passed here also. Then only if it is a two-dimensional or three-dimensional, that you have to pass a column value also. So we can run this program. So enter the elements. So you have to enter some elements, 6, 7, any elements you can enter. You have to enter 6 elements. So it is 2 by 3 matrix. So you have to enter 6 elements. Okay, then second matrix also you have to enter. You have to enter 6 elements for the second matrix. Then you have to, so this is inside the function. For addition you have to enter 1. For subtraction you have to enter 2. So let it be subtraction. I am entering choice as 2. Then you will get the resultant matrix 3 2 1 and 380 minus 380 minus 4 will be printed. Okay, so this way you can do this function. So whenever you want to pass two-dimensional matrix, so what you have to do, you have to pass a column value also. So that column is also important. Okay, so this is how we can manipulate this arrays. So then I have another exercise. So we have already done all these programs, print the prime numbers up to n. Now you have to use function for that. You have to call some function, and inside that function you have to do this operation. Then check whether the number is Armstrong number or not. You have already done this program. Now you have to use the same program inside function you have to write. Now read a string word, store it in an array, and obtain its reverse by using a user defined function. Now you know I have already done string copy, and also you have seen string reverse function also. You know what to do when you want to reverse that. So now without using that string function, you have to use that function. You have to simply reverse that string. Then another program is a menu driven program for performing matrix addition, multiplication, and finding the transpose. Now you have to use different functions for that. You have to use 5 functions. Use functions. So first function is to read a matrix. Then you have to use another function to add those two matrices. We have to use another function to find the product of two matrices. Then another function for transpose of matrix. Then another function for display a matrix. So all these functions will be done separately, and you have to call those functions inside the main program. So these 4 programs are exercise for this function. Thank you.